Hi there, and welcome to our third lesson on linear functions. My name is Dylan. In this lesson, we'll be focusing on finding the formulae of linear functions from limited information. By the end of this lesson, you should be able to find the formula of a linear function if you know the coordinates of one point and the gradient of the function. Today we've got two learners in studio with us, Ntombi and Lerato.
Hi Dylan, my name is Lerato and it's absolutely fantastic being here.
Hello Dylan, my name is Ntombi and it's great seeing what the studio looks like.
Let's see if our friends can find this formula. The function f passes through the point 5, 4 and has a gradient of 2. Right girls, what do you say?
Okay, the graph is a straight line, so we know the function must be linear.
Then we know the formula must look like this. Y is equals to mx plus c.
But what is m and what is c? We only know one y and one x.
Well, we know m is the rate of change or the gradient.
And the gradient is 2.
So we can write our formula like this. Y is equals to 2x plus c.
But what does the rate of change mean on the graph?
It gives the slope. It's how skewed the graph is.
But that doesn't help us very much.
Now remember what we said in the last lesson. In the formula y equals mx plus c, the rate of change, or m, tells us how to move from one point to another on the graph.
Okay, but we need c.
That's the output when x is equals to 0, right?
I remember in the previous lesson we used a table just like this. The gradient is the difference between the output values when the difference between the input values is equal to 1.
Okay, but we need y when x is equals to 0. But how do you do that?
They are stuck, but they almost got it. Let's see. Look at the table. At this point, x is equal to 5, and at this point, x is equal to 0. And here, y is c. To move from x equal to 5 to x equal to 0 is 5 units back. But because the gradient is 2, for each difference of 1 in the x values, I must walk back in 2's in the table for the y values. Now on the graph, we must use the gradient to walk to the point 0c. Here's how. From this point here, which is the point 5, 4, I need to walk back 5 steps, 2, 3, 4, 5, to get to the point here where x is equal to 0. At this point, y is equal to 4. Now from y equal to 4, I must move down in 2's to get to this point down here. So let's do that. 2, 2, 2, 2, 2. So at this point, y must be equal to its original value 4 minus 5 sets of 2's. So in other words, y must be equal to 4 minus 10. Therefore, y must be equal to minus 6. So this point down here is the point minus 6. Now we know that the y-intercept, or c, is minus 6. Let's see if we can complete the formula.
We have y is equal to 2x plus c.
And now we know that y is equals to negative 6 when x is equals to 0. So y is equals to 2x minus 6.
Correct. So y is equal to 2x minus 6.
Isn't there a faster way of doing this?
Well, of course, you can just imagine what happens on the graph and use the information you have and work with the formula.
But what do you mean?
Well, we do know one x and one y value that lie on the graph. We also know that the formula for this graph is given by y equals 2x plus c. So that x and y value pair must make the formula work. So we can use this information to find c.
Okay, so make y4 and x5.
We already know that y is equal to 2x plus c. And we have the point 5, 4, where x value is 5 and the y value is 4. Now using these two bits of information, we can set up this equation. 4 is equal to 2 multiplied by 5 plus c. Do you agree that we can write an equal sign here?
Yes, the point must make the formula true.
So the left-hand side must be equal to the right-hand side. Now, Lerato, can you find the value of c?
2 times 5 is 10. So 4 is equal to 10 plus c. To solve for c, subtract 10 from both sides. So c is equal to minus 6. Therefore, y is equal to 2x minus 6.
So we've confirmed algebraically that the formula of the function is y equal to 2x minus 6. Now it's time for another example. The graph of a function g has a slope of 3. And we also know that g of x is equal to minus 4 when x is equal to 0. And we've been asked to do two things. Firstly, we need to sketch the graph. And secondly, we need to find the formula for the function. Remember, the slope is the rate of change or gradient of the function. And in this case, we've been told that the gradient is 3. So we already know that the rate of change is constant, therefore that this function must be a straight line. Now the girls are also going to do the example, and we're going to compare results at the end. What does it mean to say that the function value of x is equal to minus 4 when x is equal to 0? Well, you should remember that g of x refers to the output value of the function g when the input value is x. Now here, x is equal to 0, so we can write the statement as g of 0 is equal to minus 4. In other words, we have a point on this graph of the function g, and it is the point 0, minus 4. Let's plot this point on the Cartesian plane. All along the y-axis here, the x value is equal to 0. And all along this line here, the y value is equal to minus 4. So this point here is the point 0, minus 4. We already know by now that the slope of our line is 3, or positive 3. And by this time you should know that a graph with a positive slope lies like this, although it could also lie like that, or even like that. We need 2 points in order to fix the position of a straight line. Therefore, we need another point that lies on our straight line. And we can use the rate of change or gradient in order to find this point. Now, it is important that you know how to use the rate of change in order to do this. Remember that if m is equal to 3, for every 1 unit of change in the input values, the output value changes by 3 units. At the point 0, minus 4, we know that the x value is 0. So if we were to increase the x value by 1, we know that our new x value would be 1. On the graph, we need to move to a point where x is equal to 1, in other words, a point that lies along this grid line. But we also know that the output value must increase by 3. So from minus 4, we need to move up 3 units. 1, 2, 3, ending up at the point where y is equal to minus 1. So our second point is this point over here, the point where x is equal to 1 and where y is equal to -1. Now that we have 2 points, we can draw our straight line which passes through both of those points. Remember, this graph is a graph of the function g. Let's see how the girls did.
We have finished, but I think we have a bit of a problem.
Look, her graph looks different to mine.
You're right, they do look different. But let's check what each of you did. Here we can see the 2 graphs, one on top of the other. And we can quite clearly see that the 2 graphs are not the same. Lerato, you used the scale of 1 block equal to 1 unit on the x and on the y-axes. So, from the point here, which is 0 minus 4, you moved right 1 block or 1 unit, and then you moved up 1, 2, 3 blocks or 3 units. So yes, this is the correct position of the point 1 minus 1. Now let's have a look at what Ntombi did. Now Ntombi, I see that you have used a scale of 2 blocks equal to 1 unit on the x-axis and 1 block equal to 1 unit on the y-axis. Therefore, in order to move 1 unit in the x direction, you have moved 2 blocks across, still equal to 1 unit, and you've moved up 3 blocks, 1, 2, 3, which on the y-axis is equivalent to 3 units. So this is the correct position of your second point. So girls, you can relax. Both of your graphs were correct. The reason they looked different was because you used different scales. But just remember, it is best to use the same scale on the x and the y-axes when sketching graphs. Now, we need to write down the formula for this function. Because it's a straight line, we know that the formula is of the form y is equal to mx plus c. But we've been given the slope. We know that the slope of the graph is 3. In other words, we know that the value of m, or the gradient, is equal to 3. Therefore, the function formula is y is equal to 3x plus c. And we know that g of 0 is equal to -4. And where the input value is 0, we know that the output value is the y-intercept. So we also know that c is equal to -4. Therefore, our final formula is y is equal to 3x minus 4. Now remember to always check. Using the gradient, we found that the point 1 minus 1 lies on the graph given by y is equal to 3x minus 4. Let's check though that this point does in fact satisfy this formula. So on the left hand side, we know that y is equal to -1. There's the y value of the point. On the right hand side, we know what the x value is. We know the x value is 1. So the right hand side is 3x minus 4, which is equal to, rather, 3 times 1 minus 4, which is equal to 3 minus 4, which is equal to -1. So can you see that the left and the right hand side are both equal to -1? Therefore, we know that our calculations are correct. This is the correct formula for the graph that we drew, and this point 1 minus 1 does in fact lie on this straight line. I hope that you enjoyed learning more about formulae and linear functions. And a great big thank you to Lerato and Ntombi.
Bye. See you next time.